Chapter 4, Unit 5, Biased and Unbiased Statistics. A sample statistic is unbiased if the average value of the statistic is equal to the population parameter. For example, if the sample mean is equal to the population mean. The average value of the statistic is obtained from all the possible samples for a specific sample size n. Example, the population has 100 subjects. If we look at the mean of every one of these samples of 20 people each that we choose, then average those means together, this would be the average value of the statistic. A sample statistic is biased if the average value of the statistic either underestimates or overestimates the corresponding population parameter. So let's look at some random samples example. So say you have a population with 3 scores, a 0, a 3, and a 9. The mean is 4, and the variance is 14. Okay, so you're going to randomly choose 2 scores, and scores can be repeated because every score has a chance of being randomly selected. Think of it like if a number is chosen out of a hat, and then you put the number back in the hat, it could be chosen for a second time again. So when we're choosing 2 scores, notice over here, they did 9 possibilities when choosing 2 scores. So the first sample, shown in the diagram, the first score chosen was a 0, and the second score was a 0. The mean of that sample is 0, and the biased variance, where we used n in the sample calculation, was 0, and the unbiased variance, where we use n minus 1, like we're supposed to for a sample, gave us 0. Okay, and then they did this for 9 samples. So for example, look at sample 4. They drew a 3 the first time and a 0 the second time. That gave a mean of 1.5, a biased variance of 2.25, and an unbiased variance of 4.5. So let's examine what happens when we do a biased variance and we just use n instead of using n minus 1. Okay, so for each sample, we have the mean m, the biased variance, and the unbiased variance. And then for the 9 samples all together, you can add up all of the biased variances and you get a total of 63. Notice it's at the bottom of your chart. If you divide that by 9 samples, then the average variance for all the samples used would be 7. This is not at all close to the population variance of 14. Well, now let's look for the 9 samples at all the unbiased variances. Well, if we add those up, we get 126, and then we divide by the 9 samples, we get 14, which is exactly equal to the population variance. So this is one reason we use n minus 1 in the variance calculation for a sample, so that we can say that our sample mean estimates our population mean. Our sample variance and standard deviation estimates our population standard deviation. Another item to note is that if you add up all the means calculated for each sample, you get 36. And if you divide by the 9 samples, this is where your average mean of 4 comes in. And this is actually equal to the population mean. Okay, so it's unbiased. So the sample mean and the sample variance, which was calculated using n minus 1, are both unbiased statistics, meaning they are a good estimate for the population mean and variance. This is why we use n minus 1 for sample variance. Pause the video, see if you can do the problem. So a researcher takes all possible samples of n equals 4 from a population and computes a statistic for each sample, and then calculates the average of all the statistics. What's the most accurate? Well, if the sample statistic overestimates the population parameter, then it's biased. If the sample statistic underestimates, then it's biased. But if the sample statistic is equal to the population parameter, the statistic is unbiased. These are all 3 true. They're all accurate, so it's all of the above. Learning check problem 2. Pause the video. All right, all of the possible samples of n equals 3 are selected from a population with a mean of 30 and a standard deviation of 5, and the mean is computed for each of these samples. So if you took the average of all those means that were computed, what value would be obtained? You would get exactly 30. When you take all the sample means and you average them all together, your average sample mean would be equal to your population mean, which would be exactly 30.